Hi, in this video I will explain OLSR, Optimized Link State Routing Protocol, used in mobile ad hoc network. In wired network, our routing protocol divided into two major categories. Now, what is the problem in this routing protocol? When a node sends this information also known as LS advertisement. So these information actually flooded. They actually use flooding mechanism, and this flooding mechanism a particular routing table by using Dijkstra algorithm for shortest path. Now we will see the drawback. So say we are having four node A, B, C and D. A is sending its LS advertisement. So when B receives these packet, B also broadcasts this one. So if you can see, A is already having this packet, C also received this packet already. Now C also receiving one more copy of this packet, and when C also broadcasts these packet, so every node is receiving multiple copy of the same packet. So there is unnecessary transmission of uh, packets, and plus there is wastage of network bandwidth. So in order to remove these problem, OLSR is devised. So in OLSR, the major difference in the flooding mechanism. So here we will see what is the OLSR. So in OLSR, it avoid unnecessary receive those packet, but only C will rebroadcast that packet again. B on and D will not transmit. So here is some terminology used in OLSR. So first is the neighbor node. What is the neighbor node? A node which say we are considering A. So any node that can be heard by node A is known as neighbor node. So we can say H, F, G, C, B are the neighbors of A. They are directly heard by node A. So these are the neighbor node. To hop neighbor. So in short, we can say if a neighbor and the node having distance of 2 hop, we can say that node neighbor. D is the 2 hop neighbor, E is the 2 hop neighbor. Now there is one more thing. If we follow this definition, node which can be heard by neighbor, so C node also heard by B. So according to this definition, C also a to her neighbor information, their their neighbor information, their information about state of their link to their neighbors. So for those purpose, hello packets are used. Topology control packets, these packets used to tell another node what are the MPR of the particular node. And MID packet, these packet used to inform about multiple interface. If a node is having multiple interface, so those interface information is sent by MID packets. So first we will see directional link. And whenever a node receive a hello message, each node construct its MPR selector table. We will see how every node select their MPR. So how hello packet works, say this is the mobile ad hoc network of 4 nodes A, B, C, D. So first of all, D will send hello packet to its neighbors. So when C and B receive these packets, C and B would know that D is a neighbor of, because C is sending this information. So D will find out C is my one hop neighbor. A also will find out C is my one hop neighbor. Now A will send hello message. So C, B will find out A is also their one hop neighbors, and they will update their information. Neighbors table. So it will follow the first step. It will follow the first step, which is cover isolated points of n to u. A node which is select only with one neighbor of u. So this node is connected with one neighbor of u. This node is also connected with one neighbor of u. This one is also connected with one neighbor of u. This node, if you can see, this node is connected with two neighbor of u. So that's why we will not consider this node now. So in the first step we will consider what node are isolated, which node are having only connected with single neighbor of u. So we will consider all those neighbors. So in the first step we have selected 1 2 3 4 ampere, and by selecting these 4 ampere, these messages actually contain ampere selector, a node who select ampere, and another one is the sequence number. So on the basis of this topology control message, every node also is first maintain a topology table, and then on the basis of this topology table, routing tables are calculated. So this is the information built by on receiving topology control message. This is the destination address, this is the destination ampere select a sequence number. So this sequence number actually works as a timestamp on what time this information has been received, and this is the holding time which will specify for how long a particular entry need to be in table. So let's take an example. It will clear this concept. Here A, B and C connected to M, Y, Z all are having symmetric link. So A, B and C all are having two Y and Z as a two hop neighbors, and only way to reach these one is M. So A, B, C, three of them will select M as a ampere. Okay, now T, this is the node sending this information ampere selector. It means these nodes selected M as a ampere, and this is the sequence number. So when Y receive this information, Y will C. It means node D is reachable through C. So it will find out this information D is reachable from C. Now it will search its routing table again and try to find out a entry for C. So it will find out that node C ampere is M. It means node C can be reachable by node M. So it will find out that M